Hey, pre-calc students, this is Mr. Beck. Today we're going to be talking about two sections, probably going to be in two videos. So this first video is going to be about 7.1, which is about the inverse trig functions. Today we're going to be talking about more the inverse sine, inverse cosine, inverse tan. So to begin, one of the things I like to do is take a look at the graph of two functions here. We have f of x equals x squared, and we also have x equals y squared, but we don't have all of x equals y squared. We have a limited graph of x equals y squared. That limited graph is going to be the top half of it. So the big question that we have is, does f of x have an inverse function? And the answer is no, it does not. The reason why it does not is because it is not one-to-one. So in order for you to have an inverse function, if you remember from chapter 5, you must have a one-to-one function, which we don't have. So in order to make f of x one-to-one, we need to limit the domain. So if we limit the domain, the way that I'm going to limit it based off of the graph here is we're going to say our domain is only going to go from 0 to infinity. So we're going to cut off this portion of the graph. And now if we take a look at these two graphs, now these are truly inverses of each other. So by limiting the domain, we're able to have an inverse function. And to find that, if you remember, we switch x and y and solve for y. So we switch x and y and solve for y. So let's do that. We have x equals y squared, and then we solve for y. We will take the positive and negative square root of x. And keep in mind, we only want the positive square root of x because of how we limited our domain here. So f inverse of x is going to be the positive square root of x. Now, what's the domain and range of these two functions? So the domain of x squared is going to be from negative infinity to infinity. Because this is the unlimited domain, the range of x squared is going to be from 0 to infinity. The domain of the square root of x is 0 to infinity, and the range of the square root of x is also 0 to infinity. Now, these two functions are not really inverses of each other, but they are related to each other. The relation, the range does become the domain, but the domain does not become the range just because we had to limit the domain for us to be able to have an inverse function. Now, how this applies to trigonometry, the graph of sine of x is not an inverse function. So if we take a look at the graph of sine of x, and I said inverse, it does not have, or it's not a one-to-one function. Because it's not a one-to-one function, it cannot have an inverse. So just like before, what we're going to do is we're going to limit the domain. Let me go ahead and answer this. No, it's not one-to-one. Since it's not one-to-one, we must limit the domain. And the question is, how are we going to limit the domain for it to be effective? One of the things that we can do is we could eliminate the domain. We could say, hey, let's forget about this part. Let's forget about this part. And now what's left is a one-to-one function. But I don't feel like that's going to be very beneficial for us, mainly because that's so far away from the origin. So if you see the graph below here, the graph has us limit, the graph of the inverse sine function has us limit the domain that we're not going to include anything over here. We're not going to include anything over here. That way, this region here is a one-to-one function. By having a one-to-one function, we can now limit the domain, or we can now find the inverse. So we limit the domain. And the way we're going to limit the domain is from negative pi over 2 to pi over 2. Now, what this does for us is it allows us to have angles, and these angles here, these angles are in quadrant 4, which I'll tell you right now, I am going to introduce a terminology that is not entirely kosher, but it's really more descriptive. So rather than call this quadrant 4, I'm going to call this quadrant -1. And I say this just purely as a descriptive because 7 pi over 4 is in quadrant 4, negative pi over 4 is in quadrant 4, but they're created differently. And that creation, that difference in creation is going to be very important for us to look at, that we need angles that go from negative pi over 2 to pi over 2. So I will call this quadrant -1. Keep in mind that doesn't really exist, but again, it's very descriptive. So to find the inverse function, we are going to go ahead, switch the x and y and solve for y. So x equals the sine of y. And then officially, what we do algebraically is we take the inverse sine of both sides. So by taking the inverse sine of both sides, the inverse sine of x is just the inverse sine of x, and then the inverse sine of the sine of y, because they're inverses, they do undo each other, and we have to be careful of that, and I'll explain in time. So we just have what we call the inverse sine of x. That inverse sine of x is also known as the arc sine. So f inverse of x is the inverse sine of x. Now the domain of sine of x is all real numbers. The range of sine of x, because their ratios go from -1 to 1. Now I said that these are ratios and the domain are angles. It's very useful for us to say that because when we start talking about the inverse sine of x, you'll hear me say this a lot, the domain of the inverse sine of x is -1 to 1 because what we have are ratios and the range is now -5/2 to pi/2. And these are angles. So let's take a long look at what's going on. Let's talk about some trigonometry in the past. In the past, we said the sine of pi/6 was 1/2. What we did was we had an input of an angle, like so. We had an input of an angle, and the output was a ratio. So what we did was we used the angle to create the ratio. In this case, because it's sine, we created the opposite over hypotenuse ratio. Now what we're doing is we're going backwards. We're saying, okay, let's take that opposite over hypotenuse ratio and figure out what angle created that. Which is why if we have a function, we can only have one answer. Even though pi/6, 5pi/6, and then all the coterminal angles of that all yield ratios of 1/2, we need to say definitively what is the, if we want to call it the primary angle that creates that, which is why we're using this specific limited range. So let me talk through these problems a little bit, and I'm going to change colors to blue. So the inverse sine of 1/2, this is a very, very short notation for a very, very long question. The question that's really being asked here is what angle between -pi/2 and pi/2 creates the sine ratio 1/2. So it's a very long question to a short notation. And that's why we have the short notation, because that notation implies that you know what the range is going to be. So one of the things that I'll do as I'm drawing this out is I'll say, okay, what angle between -pi/2 and pi/2, which means we're going to close off those two quadrants. We want the sine ratio of +1/2, which if you remember on the unit circle, that would be the y-coordinate of 1/2. What angle gets created, so you'll see also that I'll typically call this theta, say we know that theta is going to be pi/6. So for part B, we're going to do the same thing. This is a positive ratio. So what angle between -pi/2 and pi/2, because it's a positive ratio and it's the inverse sine, what angle creates the y/r, or the, on the incircle, the y-coordinate -√3/2, oh, +√3/2. Jumping ahead of myself there. So what angle creates that? That angle that creates that is pi/3. So for C, now we have a negative ratio. So what angle between -pi/2 and pi/2? That's supposed to be a -1 right there. I've corrected that and it still hasn't fixed. So what angle between -pi/2 and pi/2 creates the y-coordinate on the unit circle, or the sine ratio of -√2/2? The angle that creates that is -pi/4. For D, what angle between -pi/2 and pi/2 creates the sine ratio of -1? So that angle right there is -pi/2. Sorry, I'm having a little bit of issue with my technology here. So -pi/2. What angle between -pi/2 and pi/2 creates the sine ratio of the square root of 3? And this answer is not possible. Now, the reason why it's not possible, I'm going to show this a little bit more geometrically. That's supposed to be a positive ratio. So the y is square root of 3 and the radius is 1. And this is not possible because there is no triangle that allows this to happen. That's mainly because the hypotenuse must be bigger than the y value. So we have to be careful because some of these ratios are not possible to do. And one of the things we'll say is this is not on the interval -1 to 1. So that's not part of the domain, not in domain. If you tried this in a calculator, it would actually give you a domain error. So we could do the same thing for cosine Now with cosine, when we limit our domain of cosine to be able to have an inverse, we will limit it so that it's from 0 to pi. So that way we do have a one-to-one function on this interval. Now what this means is this represents quadrant 1 and this represents quadrant 2. So we're going to be using the angles only in quadrants 1 and 2. So the domain of cosine, like normal, is negative infinity to infinity. The range of cosine is negative 1 to 1. That's not new. But the domain of the inverse cosine, negative 1 to 1, still not new. But the range of the inverse cosine is what we care about. The range of the inverse cosine has to be an angle in quadrants 1 or 2. So what I'm going to do is I'm going to do 6a. And I'll say what angle between 0 and pi creates the cosine ratio of negative 1/2. And that angle is 2 pi over 3. And then for c, what angle between 0 and pi creates the cosine ratio of square root of 2 over 2? That's not supposed to be 0. That theta is pi over 4. When it comes to tangent and inverse tangent, the tangent graph is in red, and that's what I'm scratching out to say, okay, it wasn't 1 to 1 unless we do it this way. So tangent is kind of like sine, because tangent and sine are both odd functions, that we will use quadrants negative 1 and 1 to represent what the range of the inverse tangent is going to be. So the domain of tangent is all the x's such that x does not equal, got ahead of myself there, x does not equal negative pi over 2, which is one asymptote, and then pi n, which is every asymptote after that. The range of tangent is all real numbers. If we take a look at the graph, we can see that the slopes go from negative infinity to positive infinity. The domain of the inverse tangent means we could take any of those slopes again and figure out what the ratio is. But the ratio that we're determining that creates the slopes, that ratio has to be, or what angle creates that? That angle has to be between negative pi over 2 and pi over 2. Again, quadrants negative 1 and 1. And the reason why I'm using parentheses on that is because these are vertical asymptotes, which means negative pi over 2 and pi over 2 are not actually part of your original domain, so they can't be part of the range either. So when it comes to b, the inverse tangent of square root of 3 over 3, we will say what angle in quadrants negative 1 or 1 creates the slope of the square root of 3 over 3, and that would be the angle pi over 6. What angle between negative pi over 2 and pi over 2 creates the slope of negative 1? That angle is negative pi over 4. So with that in mind, we're going to actually find inverses, and notice how with this problem, we're finding the inverse. We have already restricted the domain of f, so we could use that restricted domain. So we're going to go ahead and say the domain of f has been restricted already. So that's from 0 to pi. The range of f. To find the range of f, we have to kind of look at the graph of 4 cosine of x minus 3. That is a vertical shift down 3. And this is going to be the primary period of cosine, if you remember from chapter 6. So the amplitude of the cosine graph was 4. So this is going to be negative 3 minus 4 to negative 3 plus 4, or negative 7 to 1. And I'm going to go ahead and do this right now because these are going to be true inverses of each other. The domain of f should be from negative 7 to 1, and the range of f, inverse, should be from 0 to pi. Now, after I find the inverse, I'll show you why that's going to be true. So x will equal 4 cosine x minus 3. We'll have 4 cosine y minus 3. I'm writing them a little too fast. So we have to add 3 to both sides and then divide by 4. And now we will take the inverse cosine of both sides. So the inverse cosine of x plus 3 over 4 will equal the inverse cosine of the cosine of y. So these undo each other and we get f inverse of x. And this is the inverse cosine of x plus 3 over 4. So let's go ahead and tie some information together. Because this is the inverse cosine function, we know that the range of the inverse cosine should be 0 to pi because it gives us an angle between 0 and pi. Now, when it comes to the domain, if we plug in -7 to the domain, what happens is we will have the inverse cosine of -7 plus 3 over 4, which is the inverse cosine of -1, which will be the smallest value that we can plug in there. If we plug in the 1 plus 3 over 4 will be the inverse cosine of 1, which would be the largest ratio that we can plug in there. So the reason why our domain is what it is has to do with what is the smallest and what is the largest x value we can plug in there so that we have the interval from -1 to 1. When it comes to the inverse tangent graph, what ends up happening with our inverse tangent graph, domain, we already said is restricted, and that's so that we can have an inverse. And if you are ever asked to find an inverse, the domain will already be restricted so that it's 1 to 1. The range of this, because it's a tangent graph, is from -infinity to infinity. Just a quick reminder that tangent graphs will look like that, which is why the range is -infinity to infinity. What that means is the domain of f inverse is going to be from -infinity to infinity, and the range of f inverse is going to be from 4 minus pi over 2 to 4 plus pi over 2. And again, I'll show you why that's going to be true after I go ahead and do this problem. So x equals 3 tangent of y minus 4. So x divided by 3 is the tangent of y minus 4. If I take the inverse tangent of both sides and then add 4, I will get f inverse of x will equal the inverse tangent of x over 3 plus 4. So the domain of an inverse tangent is all reals, which is why that domain is what it is. Now, when it comes to the range of the inverse tangent, I'm actually going to refer to this graph just because it's a little cleaner. This is the graph of inverse tangent. That inverse tangent plus 4 means we would have a vertical shift up 4, which is why we would have 4, we go from 4 minus pi over 2 to 4 plus pi over 2. That's why our range is what it is. Let me go ahead and take those up. So now let's get into the problems. My goal is to find the sine of the inverse sine of 1/6. So the first thing that I'm going to say is this an angle or is it a ratio? And the answer is this is a ratio. And the reason why it's a ratio is because this is an inverse sine. So the sine of the inverse sine, what's actually happening here is we could draw this out. Our problem is asking is what's the sine of some angle theta? So what's the sine of some angle theta? To find the sine of that theta, we're going to say, okay, this inverse sine of 1/6 means the angle is created from the sine ratio of 1/6. But now, the second part of this problem, what I'm going to do in like a greenish, is what's the sine of that angle? Well, sine is opposite over hypotenuse, so that ends up giving us 1/6. So what happens is the sine of the inverse sine cancels each other out and you get 1/6. This should hopefully make sense because they're inverse functions, but we have to be careful and you'll see why. Second one, the sine of the inverse sine of -2/7. Remember, we're in quadrant -1 because the ratio is negative. So our problem's really asking, what is the sine of theta? Well, the sine of theta, once again, is going to be opposite over hypotenuse, which gives us -2/7 again. Now for C, when I draw this out, the cosine of the inverse cosine, this is asking for the cosine of some theta. Well, let's draw out the triangle. Because it's a positive ratio, that theta is in quadrant 1, and the cosine ratio is adjacent over hypotenuse. Now, if you'll notice, we can't actually do this problem because this triangle has a hypotenuse bigger than the adjacent, so this is not possible. And that's something you have to be very, very careful of, that the problem has to be possible for you to be able to do it. For D, our question is, what's the tangent of the inverse tangent of -pi over 2? Well, is that an angle or a ratio? This is a ratio, and we know it's a ratio because it's an inverse tangent. So if I draw this out, it's a negative ratio, so we are in quadrant -1. So the ratio for tangent is opposite over adjacent. So it's -pi over 2. And then the question asks us, what is the tangent of theta? tangent of theta is one more time negative pi over 2. So be very, very careful that you're thinking through the problem. And this it's a ratio that looks like an angle. So you've got to be very, very careful. Now, we end up with negative pi over 2 because they undo each other, and that's part of the point. When it comes to number 7, suddenly we have the inverse on the outside. Since we have the inverse of the outside, one of the things that we do need to do is look at this and say, can we do this problem numerically or not? Do we know the sine of pi over 6? The answer is yes, we do know the sine of pi over 6. The sine of pi over 6 is 1/2. Now the second part of this problem says what angle from negative pi over 2 to pi over 2 creates the sine ratio of 1/2. And that answer is pi over 6 again. So this problem, they do undo each other, which is great, but this answer is not -4, or is not 4/3, or 4 pi over 3, excuse me. It is not 4 pi over 3. So they don't just undo each other, we have to be careful. Let's figure out why. This problem says the inverse sine, and the sine of 4 pi over 3 is negative square root of 3 over 2. And now this problem asks us what angle between negative pi over 2 and pi over 2 creates the sine ratio of negative square root of 3 over 2. And that angle is negative pi over 3. So this does not undo each other because 4 pi over 3 is not in the range of inverse sine. So we're going to have to do a lot of these step by step by step. For part C, the cosine of 4 pi over 3, we're at the same angle. So the cosine of 4 pi over 3 is -1/2. So the inverse cosine of -1/2 says what angle in quadrants 1 or 2 gives us the cosine ratio of -1/2. And that is going to be 2 pi over 3. For part D, so again, we could do this one numerically. The cosine of negative pi over 2 is 0. And now the inverse cosine of 0 says what angle between 0 and pi creates the cosine ratio of 0. That angle is pi over 2. For E, the inverse tangent of the tangent of 5 pi over 4. The tangent of 5 pi over 4 is +1, not -1. Now the inverse tangent of 1 says what angle in quadrants 1 or -1 give us a slope of 1. And that answer is that angle pi over 4. For F, the tangent of -5 pi over 3, let's do a quick graph of that. -5 pi over 3 is going to be up here. So we can really say that's coterminal with pi over 3. So the inverse tangent of the tangent of pi over 3, I'm changing it because it's the same slope. Now, and I'm going to do a shorthand on this one because since pi over 3 is on the range of inverse tangent, they will undo each other. Now, if we do this numerically, it's going to be the inverse tangent of the square root of 3, which says what angle quadrants 1 and -1 give us the slope of the square root of 3. And that is pi over 3. All of these problems we can do in a graphical way. I'm going to go ahead and spend more time on the numerical aspect of this. Then I'll quickly talk about the geometric aspect. Now, this problem has to be done numerically because they are not the same function, or they don't come from the same function. So the cosine of 2 pi over 3 is -1/2. Now the inverse sine of -1/2 says what angle quadrants 1 or -1 give us the sine ratio of -1/2, and that is -pi over 6. For H, the sine of -pi over 2, we know that the sine of -pi over 2 is -1, and then the inverse cosine of -1 says what angle from 0 to pi has that cosine ratio of -1, and that would be pi. I'll go ahead and put that there. So that is pi. Now, when it comes to the geometrical aspect of it, one of the things that we can do, and I'm going to say this kind of quickly, is if we know that this is the angle that we're referring to, let's figure out what angle on the range has the same y ratio. And then that way, we can just reflect it over the y-axis so that we can get that angle -pi over 3. When it comes to C, we had 4 pi over 3. Because we wanted the cosine ratio, we wanted the same x value, but in the proper range, which is why we reflect it over the x-axis. So that's something we're going to pursue as we do some more problems, but we do want to look at this in somewhat of a geometrical way as well. Now for these solving are sort of straightforward. Solve by first dividing by 3. Now I will take the sine of both sides. And by taking the sine of both sides, the sine of 2 pi over 3, we know is going to be the square root of 3 over 2. So that is our answer. For part B, first thing that I need to do is divide both sides by 6. So the inverse cosine of 3x equals reduced as 5 pi over 3. Now 3x will then be the cosine of 5 pi over 3. And the cosine of 5 pi over 3, if you remember, is going to be positive 1/2. So x ends up being 1/6. And we can check if we wanted to. 3 times 1/6 is 1/2. The inverse cosine of 1/2, let me write this down for you. The inverse cosine, 6 times the inverse cosine of 1/2 is 10 pi. The cosine, inverse cosine of 1/2 is supposed to be 10 pi. Write that. So the inverse cosine of 1/2 is going to be pi over 3. Interesting. So that's supposed to be 2 pi. I'm going to have to look at this. Let me scratch that for right now. Let me look through that one more time. Anyway, going on to this problem. One of the things I notice is these two terms are exactly the same. So I'm going to subtract. I'm going to subtract 3 times the inverse tangent of 2x. So I will have 3 inverse tangent of 2x equals pi. So the inverse tangent of 2x will equal pi over 3. So 2x is the tangent of pi over 3. Tangent of pi over 3 is the square root of 3. So x ends up being the square root of 3 over 2. So this one I think has no solution because it's not actually going to work. I'll look at that a little bit more. I'll try not to do that to you guys to concern you too much. But anyway, hopefully you're okay with 7.1. Feel free to ask me any questions if you have them. Take care.